This exambite video will walk you through an exam-style question for Achievement Standard 90937, Physics 1.3, demonstrate understanding of aspects of electricity and magnetism. This video will meet objectives related to the current electricity section of this Achievement Standard. The picture to the right shows a toy fire truck. The truck has a siren, a flashing light, and two headlights. The diagram below shows the electrical circuit used to power these components. The circuit has a 12-volt power supply. All the components are connected in series to each other. You're also given important values in the diagram. The voltage of the power supply is 12 volts. The resistance of the siren is 10 ohms. And the resistance of the headlights is 4 ohms each. Note that you are not given the resistance of the flashing light. You are told that the total resistance of the circuit is 24 ohms. You are then asked to calculate the combined voltage lost across the siren and the flashing light together. Step 1. We need to calculate the resistance of the flashing light. We know enough from the information in the diagram to do this. The resistance of the flashing light is equal to the total resistance of the circuit minus the resistance of the other components. We can use this calculation because when calculating the total resistance of resistors in series, we simply add the individual resistances together. R total equals R1 plus R2 plus R3 and so on. So the resistance of the flashing light equals 24 minus 18, which equals 6 ohms. Step 2. Calculate the current flowing through the circuit. Use the equation I equals V over R, where I equals current, V equals voltage, and R equals the resistance. This equation is obtained by rearranging V equals I times R. Substitute in the values for V and R. V equals 12 volts, as this is the voltage being lost through all the components. R equals 24 ohms, as this is the total resistance of all the components in the circuit. The current works out to be 0.5 amps. Note that because the circuit is a series circuit, the current is the same at all points. Step 3. Calculate the voltage across the siren and flashing light. Use V equals I times R. Substitute 0.5 as the value for the current. The resistance is calculated by adding the separate resistances together for the siren and flashing light. We can do this because they are in series. So you can use the sum of the resistances of the siren and light, or you can calculate each individually and then sum their results together. Note that you will reach the same answer. So back to the calculation, we see that the voltage lost equals 8 volts. Remember, visit www.nztutor.co.nz for more helpful learning resources.